Welcome to our presentation titled Automatically Predicting Bug Severity Early in the Development Process. I'm Jeremy Bradbury, and this work was co-authored by Jude Arokiam. Bug severity is defined as the impact a bug has on the successful execution of the software system. Bug severity ratings are a common attribute of most bug reports, including the example of a trivial bug on the right side of this slide. Automatically triaging bug reports by severity has been previously addressed in the literature. For example, Severity is an approach that trains a keyword-based classifier using bug reports from the current project. The main challenge of this method, and others like it, is that it can actually take 70 to 90% of a project's bug reports to properly train the classifier, thus delaying when the triaging can be used in practice. This training limitation was the main motivator for this research, as we believe that in order for automatic bug report triaging to be effective in practice, it must be useful early in the development process, ideally from the first occurrence of a bug. Building on our motivation, we hypothesized that bug reports from an organization's past projects could be the key. More specifically, the way past project bug reports are written could be leveraged to accurately predict bug severity in a new project. We have developed a supervised learning approach that differs from previous work by using features of past projects instead of building a classifier by relying on the presence or absence of keywords in the current project's bug reports. In our approach, when a new project is initiated, the classifier is already trained and can predict bug severities immediately. We have evaluated our approach by comparing it with the Severity tool using the NASA PITS dataset. This is a dataset of bug reports from 5 actual NASA robotics missions that are labeled with severities from 2 to 5, with 2 being the most severe and 5 being the least. In the interest of time, we'll only discuss our results with respect to F measure. From this first bar graph, you can see that our approach outperformed Severity in 3 of the 5 PITS projects, despite Severity being trained on data from those same projects. Furthermore, our method is effective at predicting bugs from the beginning of the project's history as opposed to from after the training has been completed. We ran separate experiments to assess what the best historical training data was for a given NASA PITS project. For example, should it be trained individually on one other project, pairs of projects, etc. The variations in the F measures for PITS C and D in particular show that not all historic data is effective. Thus, our method is only viable when the training data is representative of the test data. In conclusion, we have presented our new idea of using the past project bug reports to predict the bug severity from the start of a new project, and this work does not require any project or domain-specific classifier features. Our emerging results from the NASA PITS dataset show our approach does require semantic similarity between the bug reports in the historic and new projects to be successful. If you're interested, please look at our paper as well as all of our source code and data, which is available on GitHub. Thank you very much.